So we're going to do 9.1, 9.2, and 9.3. Okay, 9.1 is perimeter. And perimeter is how far it is around something, the distance around, okay? If you were going to put a fence around something, you would be putting the fence around the perimeter, okay? If you just have, what do you call it, shape like that, say this is 5, 4, we'll make these meters. 3 meters, 2 meters, and 5 meters. What's the perimeter of that figure? Add them all up. You got 10, 14, 15, 16, 17, 18, 19. The perimeter would be 19 meters. Okay? The perimeter doesn't have a squared or cubed or anything. It doesn't have a number. Perimeter is always just one unit. Because that's like how many feet of fence or how much you have to put around something. Okay, if you have a rectangle and it tells you this is 10 and this is 5 centimeters, what would the perimeter of that be?
10 times 5?
Adding it up, adding all 4 sides. Okay, yeah, 30. Because you got 2 10s and 2 5s. So 10, 20, 30 centimeters. Okay? If you have a square, it'll usually only tell you one side because you know it's a square, they're all the same. So if you have a square with the side 2 meters, what is the perimeter?
8.
2, 4, 6, 8. Yeah. 2 times 4, or 4 times 2. So 8 meters. Okay, that's the simple perimeter. Most of you probably could have got that just by looking in the book and doing a little bit. So you get, this is still pretty simple, just add up every side, right? That's still pretty simple perimeter. This is rectangles, so don't forget there's rectangles. If it's 2.5 by 100, make sure you add 100 twice and add 2.5 twice. Okay? And if square, it only tells you one side, so make sure you do it times 4 or add it 4 times. Okay? That's the easier perimeter. Okay? On number 22, I don't know if it says a carpenter is building a fence around something. Okay? It wants to know how many fence posts. I think the way I solve this is I actually draw the picture out. Okay? Because if you have a side that, this says it's 9 by 12. Okay? This side is 9. It says there's a fence post every 3 feet. Okay, if you look at 9, if you divide that by 3, you're, oh, okay, 3 fence posts. But there's really not just 3 fence posts on that side. Okay? You think 9 divided by 3, it's 3, but it's not. You have 1 on each corner, right? And then 3 feet, 3 feet. See, 3, 6, 9. There's 4 fence posts on that side. So, to me, it's the easiest just to draw it out. For 12 of them, you need 3, 6, 9, 12. That's not very even. This would be more like right here. Okay? So you're going to have 1, 2, 3, 4, 5 on that side, aren't you? We need 3 of them over there. We need 2 of them over here. Now just add them up, okay? Mark where you started so you don't recount the same one. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14. Don't count that one again. So 14 fence posts. You wouldn't have been able to just divide by anything to get that. You really need a picture. Okay? And it says they cost so much, so you need to put the cost times that to see how much it's going to cost you. All that. Okay? We're going to go ahead and go into area. Does anybody have any questions over the perimeter? Look over 9.1. No questions over 9.1? Okay. Yes or no? No? Okay. 9.2, area. Okay, the area of a square or a rectangle. The area of a rectangle is the length times the width. Okay. A square would pretty much be the same thing because you're doing this times this, right? But they call it S for side of a square. So it's the side times the side, or side squared. It's still length times width, right? The area. So let's do some area. Let's say we have a square and this side is 2. Remember the perimeter we did, perimeter was 8, right? This is not going to be the same as perimeter. Area is saying you have 2 here and 2 here. How many squares do you see there?
4.
4 squares in there, right? If it's 2 this way and 2 this way, you multiply length times width, 2 times 2. That means you have 4 square meters in there, because this is meters. You have 4 square meters. That would be used like to tile a floor. The area of your floor would show you how many tiles you needed. Let's say you have a room that is, okay, let's say this is a small room because it's only going to be 4 feet this way. And 1, 2, 3, 4, 5 feet this way. So you have a room 4 by 5. Your room is 4 by 5. So how many tiles do you need?
20.
4 times 5. You need 20 square feet tiles. It's a foot by a foot. These are square feet. Your area here is 20 square feet. Okay, let's do a parallelogram. It's almost the same. You still use this number here. If this was like 5 right here. And it doesn't matter how long this is right here. What matters is how tall it is. The height of it. Okay? Let's say the height is 3 inches and the base, they call the bottom of it the base. The area of a parallelogram is the base times the height. Okay, so the base is 5 inches, height is 3 inches, so the area is what?
15
15 what?
inches squared.
Square inches. Inches squared or square inches? Okay. Let's look at a rectangle and let's divide it from corner to corner. What do you see 2 of there? 2 triangles. Okay? So if you were going to do the area of a triangle, let's get rid of this part up here. The area, remember the area of a rectangle is length times width, which On a triangle, the bottom part's called the base, and this is the height. If it was this whole rectangle, we would have multiplied this times this. But we're doing half of a rectangle. The area of a triangle is 1/2 of the base times the height. Okay? So if your base was 4 centimeters and your height is 3 centimeters, your area is going to be 1/2 of 4 centimeters times 3 centimeters. 4 times 3 is 12. 1/2 of 12
6
is 6 what?
centimeters square.
6 square centimeters. And that's that triangle right there. If you would have done this whole rectangle, it would have been 12 squares. So that's how you remember that the triangle has a half in it. It's half of a rectangle. Okay, a trapezoid. Look how, let me show you the picture of this. See this trapezoid right here? If you took that exact same trapezoid and flipped it over and put it over here, this would be right here and B would be right there. And you would have had a parallelogram. And to get this whole thing, it would have been base times the height. Okay? But you're only doing half of this full base times height. Okay? The base of this is A plus B and then times the height. So when you look at the formula for a trapezoid, your base is A plus B, right here, A plus B, and the height is here, but you only have half of it. So, the trapezoid, you've got, you have to have a height somewhere. Sometimes this will come straight down, but the height is at a right angle to the base, okay? And the A plus B would be your top and bottom. So what you're going to have is you're going to have 1/2 of the top and bottom added and then times the height. That's the area of a trapezoid. Okay, so let's draw one out. This one I'm going to make the height right here. Okay, let's say the height is 3, the top is 5, and the bottom is 7. Let's go inches. Okay, the area of this will be 1/2. We're going to add the top and bottom, 5 plus 7, and then we will be multiplying the height, 3. So you'll have 1/2 of 12 times 3. 12 times 3 is 36, so 1/2 of 36 is
6 or
18.
18.
These were in inches. Remember, area has to have squared. So don't forget to put your units on every answer. Perimeter was single, area is always squared. Okay. So just your simple areas are no problem. These will be like base times height, whatever they want to call it, side times side or base times height. This rectangles will be length times width, you know, one times the other. The square, that side times itself, right? The area of a square is just that times itself. Okay, now we're gonna have some of these. You got triangle, trapezoid. You should be able to plug these into all of the things that we've done already, right? Okay, there's a problem here where you do painting costs. This one gets a little bit involved. You have a room that's 15 by 20, and the ceiling is 8 feet above the floor. Then there's 2 windows in the room that are 3 by 4, and then the door is 2.5 by 6.5. Okay, we definitely need a picture. We need something to tell us what we're doing here. Okay. The room is 15 by 20. Let's put it off to the side just a little bit. I wish I could put it up higher, but it doesn't want to. It doesn't have room. The room's 15 by 20, so let's kind of draw this room out. Draw it from every corner. If you draw a parallelogram, it makes it easier to draw this. Okay. Okay, it said that the ceiling's 8 foot above the floor, so these walls are 8 feet high. The room was 15 by 20. 15 by 20. And I'm not going to draw the windows and door in there because it would make it more confusing. But the windows, there's 2 of them that are 3 by 4, right? And it said there was 1 door, 2.5 by 6.5. 1 door, 2.5 by 6.5 feet. I think these are all in feet. Yeah, the door, the windows are 3 by 4. These are feet also. Okay. Okay. Now A asks you what is the total area of the walls and the ceiling. Okay. The ceiling is going to be the same as the floor, right? 20 by 50. Okay. Let's put A here. Let's put the ceiling on there. And how many walls do we have?
4.
4 walls. And these 2 walls across from each other are exactly the same, right? This wall here is the same as that wall. So we're going to have 2 walls that are the same plus 2 more walls that are the same, right? And then what happens when you put a window in a wall? It takes off of the area you have to paint, right? We have to subtract the windows and we have to subtract the door part because it's not wanting us to paint the doors in the window. You don't want to paint a window. Yeah. Okay, so let me shrink this down a little better. Okay, so we have the ceiling, which is 20 times 15, right? Plus, we have 2 walls that are going to be 8 foot high and 20 wide. So 2 that are 8 by 20. The others will be 15 times 8, right? So we have 2 8 by 20 foot walls, and we have 2 15 by 8 walls. Okay, that's 3 things right there. That's all 4 walls and the ceiling. Now we need to subtract the 2 windows that are 3 by 4, and we need to subtract the 1 door that is 2.5. We could put 2.5 by 6.5. 6.5. Okay? So do all of that. 10 times 15 is 300, right? 2 times 160, was that 320? And then 2 times 15 is 30, times 8 is 240, minus 2 12s. It's 24, right? And then 2.5 by 6.5 is 16.25. So if you add all those up, we have 860. Then we subtract the 24 and the 16.25. So it should come out to 819.75 something. What is that? Square feet, right?
Yeah.
That's how much square feet you have that need to be painted. That's your walls and your ceiling. Okay? From there on, you're gonna have to figure out the rest yourself. It says a gallon will cover 360.625 square feet. So you need to figure out how many gallons you need. You'll take that, 360.625, and divide it by this. And if it's not exactly, if it's like 4.2 gallons, how many gallons do you have to buy? You can't buy 4.2, can you? You're gonna have to buy 5 gallons for that 0.2, or you won't have enough. So if it doesn't come out exact, you need to go to the next gallon. That's how many gallons you'll have to buy. It doesn't say you can buy parts of a gallon. And so you'll need to figure out how many gallons you need, and then it tells you how much the gallons cost. You're going to do that, you'll do this 360 and divide it by the 819. Okay? Then you'll have to multiply it by the price to see how much it's going to cost you, right? Okay, that was one that people had a little bit of trouble with. Okay, how about, we got some pictures here. You were going to do number 43, the area of that. That's not a shape that we have a name for. But you can divide it up into shapes that we do know. If you draw straight lines here, what do we end up with? 5 squares. So you're going to do 5 times each square. Each side is 4 centimeters. You're going to do 5 times 4 by 4. That'll give you the area of that. Okay? The area of this thing, you can either divide it up like this, and you could add this part, and this part, and this part. That would be 3 things you have to add up. Or, the easier way that I would rather do myself, I would divide it over here, and I would get this whole rectangle and say I cut that part out. Okay? This you can get, you've got the sides right here, 11 by 12.5. The part that you subtract out, this part is 5. You have to figure out what this part is. How can we find this distance? There's 2 and 3 right here. You make it a little bigger so it's easier to see a little bit. There's 2, there's 3, so there's 5 right here. Yeah, if we take 5 from 11, there's 6 left. So this is 6 by 5. So once you multiply this, then you could subtract 6 times 5, which is 30. So you could subtract 30 from it. Okay, let's look at this next one here. Okay, this one, I would divide it right here, And we have a square, 30 by 30, and you're gonna subtract what? Subtract a triangle, right? This triangle is 1/2 base times height. The base is the same as the bottom, which is 30. So do 1/2 of 30 times 15. Subtract that from what you got as the whole thing, right? Catching on, huh? Okay. 46. What would you do there? It already has it made into a rectangle, doesn't it? Do the base down here times the height, then subtract that triangle and subtract that triangle. Okay, here's one right here. Okay, we've got a triangle right here. We can figure out a triangle, right? 1/2 of the base times the height. And then it says each one of these little steps, it says each small triangle has a height and a base of 1. So 1/2 of base times height. 1/2 of 1 times 1. 1/2, right? Each one of these small triangles has an area of a half. 1/2 of 1 times 1. So you have a half, 1, 2, 3, 4, 5, 6 times. So these steps have an area of 6 times 1/2 is what? 1/2 of 6. 3. So the steps have an area of 3. You're going to add 3 to this other area. This one right here, tell me what you're going to do. First, you're going to do the area of the big part, right? And then you're going to subtract off what?
Or the parallelogram.
Subtract the parallelogram, which is base times height. It doesn't say the height here, but it says the height over here.
Yeah.
So this parallelogram is, the base is 9. If it said it up here, it's the same as here.
Yeah.
9 times 7. So do this whole thing, subtract 9 times 7. Okay? So that's 9.2. Now we're going to go to 9.3. Circles get a little more involved. Okay, circle. First thing it tells you about a circle, you got to know the parts of a circle first. If you go from side to side, the longest, not like up here to side, it's got to be the longest right here. It goes through the center of the circle. From side to side is your diameter. Okay? If you only went from the center to the outside, that's called your radius. If you measured from one point and you measured all the way around it, that's called your circumference. That's like the perimeter of a circle. It's how far it is around it. Okay? It's not called the perimeter of a circle, but it's like the perimeter because it is the same. It's how far it is around. Okay? So, let me tell you how they came up with how far it is around a circle. Okay, back in the Greek days when they were figuring out all kinds of math stuff, I don't know if they had string or what they used. They had to have string because they made cloth. So they used some kind of a string. And what they did, every circle they came across, they'd measure the diameter. And then they would take that string that was that long and see how many times they could wrap it, how many diameters there were. So there was 1, 2, there was 3 diameters and a little bit more. It never comes out exactly the same, okay? And if you do this now, the circumference will be the diameter times how many times it goes around there, which is 3.14. Yeah, it's called pi. Okay? That's where they came up with pi. The only thing you'll ever use pi on is circles, because that's what it means, is how many times that diameter goes around the circle. So if we knew a diameter was, let's say the diameter is 10 inches, we could figure out how far it is around it, because we would say the circumference is that diameter times 3.14, okay? Which is 10 times 3.14. When you multiply by 10, you can just move your decimal, right? So it's 31.4 inches. And like perimeter, this is only a single unit. That's a measurement how far it is around, how many inches around it. So that's how you find it. What if you only knew the radius? Say the radius is 2. Okay, if you double the radius, because there's 1 radius, and the radius from here to the outside is going to be 2 again, right? If the radius is 2, the diameter is twice that. So the diameter is 4. So the circumference would be 3.14, or pi, times the diameter, which is 4. You can put these in any order. So that would be 12.56. And I didn't have a unit here. Let's make up a unit, centimeters. So that would be that many centimeters. Okay? So if you double the radius, you get the diameter. You see how far it is across. Okay, let's find the perimeter of something that's a funny shape. Let's find the perimeter of something like this. Okay, let's say this is 8, this is 10, and this is 10. That's all that they gave you. Let's say inches. And it wants you to find the perimeter. Okay, this part's easy, right? You add these. What about this? This is only half of a circle. We only know how far it is around a whole circle, don't we? The circumference is how far it is around a whole circle. So we're going to figure out how far it would be if it was a whole circle. But it didn't give us a radius, did it? It didn't give us a diameter. Okay, when they draw pictures like this, you have to assume that these are all right angles. And this length over here will be the same as this right here. So it's going to have a diameter of 8 if it says 8 over here. Okay? So we need to add 10 plus 8 plus 10, plus we need the distance to go around half a circle. So we have 10 plus 8 plus 10 plus the whole circumference was pi times diameter, right?
Yep.
Okay, so let's do half of that. Let's do half of pi, and what was the diameter? 8, right? So the straight parts add up to 28, right? Plus 8 times 3.14.
From 12.
25.12. And half of that divided by 2. Divide that by 2.
12,
Wait,
56.
12.56?
Yes.
Okay, so add 28 to that.
40.56
40.56. And what is our unit?
inches.
Just square. Or no.
Not squared, right? Inches, it's just how
Inches.
far it is around. So that would be the perimeter. Even though part of it's like a circumference, if it says to find the perimeter, that's how far it is around it. You're gonna have lots of combinations of different shapes you have to find perimeters of. But when it says that, it means how far it is around something. You're gonna have a lot of those. Okay, we have one of your homework problems that has 3 half circles, and then it's just connected right there. Okay? This distance from here to here, it says is 8, and it actually drew a square in here. It said that this was 8 by 8. Okay? So part of your perimeter is this 8. The other part is 3 half circles. Okay? So you're going to put 8 plus 3 of the half of a circumference, right? You have 3 of those. What is the circumference?
8.
The circumference is supposed to be pi times the diameter, right? Okay, so let's leave the 8 plus and leave that part. Pi is 3.14. The diameter was 8, right? How far across?
25.12.
8 times 3.14 is 25.12. Okay, half of that is what? Half of 25.12? 12.56, right?
Yes.
Did that a while ago?
Yes.
We need 3 times 12.56. And then you add 8 to that.
45.68.
This gave it in feet. So is this feet or square feet? We're still doing perimeter, it's just feet. Okay? The next one, I'm going to tell you what to do. We're not going to go through all the steps of solving it. I'll just tell you what numbers you need to do. Okay, we have, looks like an upside down ice cream cone. 4, 4, and 4. Actually, this could be dotted because it's not really part of the perimeter. You don't want to mix it up with the perimeter. Okay, so you're going to have 2 sides that are 4 plus 1/2 of a circumference, right? So you're going to have 1/2 of pi times the diameter plus that 8. And we're not going to finish it. I'm going to let you do that on your homework. Okay, you have another one here. Still doing perimeter. Okay. This says that each one of these are 4 yards. So you see part of it is 4 plus 4, right? How much of a circle is that? That's about a half, and that's about a fourth, so 3/4, right? So you're gonna do 3/4 of the circumference. So you're gonna have 8 plus 3/4 of, what is the circumference again?
3.14.
Yeah, pi or 3.14 times the diameter. If you look in the back of the book and it tells you a different number than what you get on these, it's probably because the book used the pi symbol on a calculator. It tells you to use 3.14 for pi, but if you actually use the pi button on a calculator, it comes out a little bit different. So if you look in the back and it's a little off, you're probably still right, okay? So don't freak out if you're not able, no matter what you do, you can't get what the back of the book says. Because it's probably because they used the pi button instead of the 3.14 that they told you to use. Okay, that's on any problem, not just this one, okay? The next one has 4 half circles, and I'm kind of messy. There's actually a straight line down there. I probably should have drawn the line first. Okay, each one of these are 8. So we know we're going to need 8, 8, 8, 8, right? 8 plus 8, 4 times. Plus, how many full circles, how many full circumferences are we going to have?
2.
Yeah, if we have 4 halves, we have 2 full circumferences. So we have 2 circumferences, and make sure you, circumference is pi times the diameter. 8 plus 8 4 times is 32. So I'm going to let you finish figuring it. These were in inches on here, so don't forget to put your units as inches. Okay, here's another shape. Okay. What's the perimeter of this? We have a 10 and a 10. How many 10s are going to be in your perimeter?
3.
3. 1, 2, 3, right? What is this going to be? Half of a circumference, right? Plus 1/2 of a circumference, which will be pi times your diameter, which is 10, right? The diameter.
Yeah.
If this is 10, it's going to be 10 up here. So we got 30 plus we have 1/2 times 3.14 times 10. And these were in yards, so don't forget to put your yards at the end after you figure that all out. Okay, how about this one? That really is half a circle. Even though these circles don't look the same, they're supposed to be a full circle. Okay, it says from here to here is 10.2. From here to here is 12.8. So the straight parts, what we have 2 12.8s, don't we? 12.8 plus 12.8. Plus, on the circle parts, how many full circles do we have? We have a half and a half.
Just 1.
One full circle, right? One full circumference. Okay, so add those. Let's see, it's 16. I shouldn't have put a 1 there because it doesn't fit anywhere in it. It's 25.6 plus, what is that again?
5 times.
5 times the diameter. What's the diameter?
10.2.
10.2. So multiply that and add that, and don't forget your units. Okay, now it jumps to area. Okay, we have to change our thoughts in our head now, because we're not just doing the outside now, we're doing the shaded area, the shaded part only. Okay, so now if we have a full circle, here's our diameter going down it, and we have circles on both sides, and I think they're supposed to be equal. And that's amazingly close. I thought it would be worse. Okay, it says that the diameter of this little circle is 8, and it's shaded all of this, all the circle except those 2 holes. So it's like they had a circle of, they cut a circle out of metal, and then they cut 2 circles out of that circle. Okay, so it really doesn't tell us this diameter right here, does it? What if we draw a line from this side to that side? If the circles are the same, this one should be 8 also, right?
Yeah.
Okay. What's the formula of an area of a circle anyway? Do you remember?
Pi times r squared.
Pi r squared. So really we don't need diameter anyway, we needed the radius. We're just so used to doing diameter, we gotta get that out of our mind for now. Okay? So let's do the area of the big circle minus the area of a little circle. Twice, right? We cut these 2 circles out. So area of the big circle is pi times, what's the radius of the big circle?
8.
From the center to the side, it's 8. That's the big circle. What's the radius of a little circle?
4.
It's only half of that. It's 4. So pi times 4 times 4. Not 4 times 2, guys. 4 times 4. You have to multiply these, not times 2. So we're going to have, on this one, 3.14 times 64, 8 times 8. This will be 3.14 times 16, 3.14 times 16. Okay, so find that one, and then you're going to subtract this and subtract that. So you might go ahead and multiply this first and write that number down, so you'll be able to subtract it after you find that. You'll subtract it 2 times, or you could just do 3.14 times 64, and you're going to subtract 2 of the 3.14 times 16s. So you could do it either way. What will our units be here? It had 8 meters. Okay, so when you find your answer, it's going to be meters squared. Area is squared, remember? Because we did meters times meters, 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 meters. So it's square meters. Okay? So that's how you're going to figure that one out. Remember our upside down ice cream cone? Now we have a right side up ice cream cone. But we're not doing perimeter this time, we're doing the area. Okay, from here to here, which means from side to side, is 2.8. It it says from here to here, which would be the height of the triangle, is 2.8. Those are both centimeters. Okay, the area, we know area of a circle was what?
Pi times
Pi r squared. We don't have a whole circle,
take half.
half of a circle, right? So we're gonna do the area of a half circle. Is 1/2 of pi r squared, right? Plus, we're gonna add the area of the bottom, which is a triangle, right?
Yes.
Triangles are
Half base times height.
1/2 base times height. Okay? So you're gonna put all those numbers in. I'll help you a little bit because it's hard to remember the radius part of that, okay? Area of the half circle is 1/2, 3.14 times radius. Don't use 2.8 for your radius. That's how far it is all the way across. Remember, radius is only half of it, so the radius is what? 1.4. So do 1.4 times 1.4 for the half circle part. Do all that. Figure out your whole triangle part. 1/2 base times height. What's the base of the triangle? The base is the whole thing, right? 2.8. The height of it, 2.8. So figure that number out, figure that number out, and subtract them. Okay. This one right here, oh, I went too far. Okay, looks like Pac-Man. All right, so how much of a circle is that? 3/4. The area of the whole circle is pi r squared. We're only doing the area of 3/4